Okay, so we're into lipogenesis. All right, so this is making fat. Okay, so we're building up to make fat. So when you eat more glucose or carbohydrates than your body needs, your system is going to use the acetyl-CoA to turn that excess into fat. Okay, and again, this takes place in those adipocytes or the fat cells and the hepatocytes, which are liver cells. So for protein metabolism, the digestion of proteins begins within the stomach, okay? And so in the stomach, we have the pepsin and the hydrochloric acid, and then down into the intestine, we have secretin and CCK, and then the acinar cells of the pancreas, they release trypsin and chymotrypsin and elastase and sodium bicarbonate. So the protein, the amino acids can be broken down into those precursors for glycolysis or the Krebs cycle. The amino acids that are in the bold can actually enter the cycle through more than one pathway. Okay. Amino acids that are then transported into the bloodstream for dispersal to the liver and the cells throughout the body to be used to create new proteins. Those amino acids are going to be processed and stored as glucose or even as ketones when they are in excess. But you can see that they can enter into the Krebs cycle at many different areas. Just depends on which amino acid it is, right? So here, the glucogenic amino acids are alanine, cysteine, glycine, serine, and threonine. Okay, and so those can all go right here. Look, there's tryptophan, everybody's favorite amino acid. And that one can go in to do ketone oxidation at acetyl-CoA. So this is just showing you kind of that whole process of what we're doing. Okay, so here's glycogen. Remember, glycogen is our storage molecule. So in order to break down glycogen, we do glycogenolysis and we turn it into glucose. When we have excess glucose, we can build it up, add them all together to form glycogen, doing glycogenesis. Okay, and so the goal here is for you to understand those different processes of what are we doing. Okay, so here, okay, we can break down the glucose into the pyruvate molecules and we do glycolysis. We can also build up those pyruvate molecules and do gluconeogenesis. Remember, we do that because we can put in those extra amino acids. We can put in that extra glycerol and we can build it up to do gluconeogenesis. We can, through glycolysis, we can break down into glycerol, further into triglycerides and fatty acids. Okay, those can then enter in here at the acetyl-CoA molecule. We do lipolysis or even beta oxidation is what it's called. Okay, when we have these ketogenic amino acids, they can do ketone oxidation to form acetyl-CoA, or we can break down the acetyl-CoA and do ketogenesis to form ketogenic amino acids. I didn't mean break down, I meant add up. Okay. So when we have the green arrow is when we are building up, so we're doing anabolic reactions, and the bluish arrow, excuse me, is when we are doing anabolic reactions, so we're breaking down. Okay. There's three metabolic states. There's the absorptive state, the post-absorptive state, and the post-resorptive state. Okay. And so the absorptive state is during digestion, right? So we've just eaten and we're digesting our food. The post-absorptive state is when we are fasting. And then the post-resorptive state is then we are truly starving, starvation mode. So the absorptive state occurs after a meal when your body is digesting the food and absorbing the nutrients. So when we're absorbing and after we've eaten, we're doing more anabolism than we are doing catabolism. At this point, it's already been broken down, okay? So we've digested those nutrients, we've broken them down. They enter into the bloodstream, the blood sugar concentration rises. We are then going to start releasing more insulin so that we can take up that glucose by the body cells, okay? And then we're gonna take up into the adipose cells, the muscle cells, and the liver cells, okay? So in that absorptive state, those liver cells are gonna convert any excess glucose to glycogen so we can store it. Amino acids are gonna be converted into ketone bodies. And the muscle cells are going to convert the glucose to glycogen again as storage. Amino acids are used to synthesize actin and myosin to rebuild protein muscle fibers. Okay. And the adipose cells are going to store excess lipids to increase the fat reserves. Okay. So all of this again is after we have eaten. Post-absorptive state is when we are fasting, like overnight, for instance. Okay, this occurs after the food has been digested, absorbed, and then stored. Okay, so no nutrients are entering our bloodstream. So that means that our sugar concentration within our blood drops, right? Because we haven't eaten anything, and so that's going to trigger our stimulate our pancreas to stop releasing that insulin, and instead we're going to start releasing glucagon. Okay, and so when that happens within our liver cells, we're going to do glycogenolysis. We're going to break down that glycogen and we're going to release the glucose into the blood. We can then return that blood concentration up to normal. You can also do ketone oxidation, which is going to release the lipids and additional glucose. Those body cells can then use that to generate ATP. The muscle cells can release the glucose into the blood. And we can do ketogenesis there. And then in the post-absorptive state, those adipose cells are going to release those stored lipids, which can then be used to generate glucose, ketone bodies, or even ATP. This is our starvation mode. And so for the first 7 days, we can maintain our blood glucose. And we do that by doing all of these areas, right? But then after we pass 7 days, we can do what's called protein proteolysis. That protein proteolysis, where we're breaking down those extra proteins, decreases because these are essential proteins and we can't use them over a long period of time or it's going to compromise our organism. And then after that, we can switch to using ketone bodies. So as far as thermoregulation or energy and heat balance, most of our energy is derived from the food is actually released as heat. Okay, and so it's tightly regulated by our hypothalamus. There's different ways that we can release heat. One of them is convection, and that's when we transfer the heat to air or water. Okay, and so that would be like the temp. When you have a fever, for instance, you can actually put your hand like over somebody but not touch them, and you can feel the heat sort of coming up off of them. Conduction is the transfer of heat from one to another. This is direct contact. Radiation is when we transfer heat via infrared radiation. And then evaporation transfers heat as water changes state from liquid to a gas, like when we have that evaporation of our sweat off of our skin. Okay. And so when our body temperature is low, remember we have our temperature receptors in the hypothalamus and they stimulate our heat producing mechanisms. One of them is that our superficial arteries are constricted, so we're going to reduce that heat loss by the air. We're going to reduce that convection heat loss. We're also going to start to shiver. So that's going to increase our aerobic respiration in the muscles so that we can release heat. And our thyroid cells are going to increase our metabolic heat production. So we're going to increase our metabolism. Then when our body temperature is too high, our temperature receptors are going to initiate our heat releasing mechanisms, like we're too hot now. So the superficial arteries get dilated. They're going to cause some flushing. So we're going to, like, our skin is going to appear to be red-ish. The blood flow is not diverted away from our digestive system. We start to sweat so that we can do that evaporative cooling effect. And then our thyroid cells are going to stop doing that metabolic heat production. Nutrition and diet. So more energy is required to break down fats and proteins than carbohydrates. Typically, people need about 1,500 to 2,000 calories for a normal daily activity, and all excess calories that are ingested will eventually be stored as fat within the body. Vitamins and minerals are essential parts of the diet. Vitamins can not be stored by the body, so the excess gets excreted, and minerals can be stored, specifically in our skeletal tissue, like calcium, for instance. So the questions become, can you do all of these things? These were our goals for this lecture. So give it a shot, write down these questions, and see if you can answer these. See you guys later.